Hello, everyone, and welcome to our webinar on the top transformational technologies reshaping the world. My name is Mike Coleman. I'm a Vice President for Research here at Lux, and we'll be hosting the webinar today. In a few minutes, I'll have a chance to bring in several of my colleagues, Chris Robinson, Yuanqing Yu, and Danny Brandon, to help with the discussion of some of these emerging technologies that we're covering today. But before we begin, just a little bit of housekeeping. We will have some time for Q&A at the end of this session. So if you do have any questions, please type those into the Q&A box on your screen. We'll get to as many as we can during the session, but we'll certainly follow up with you as well if we're not able to get to your question. And we will be sending around the slides as well as a recording to all of the attendees afterwards as well. So with that, let's get started. We are here to talk about our Foresight 2021 report and study from Lux, which I was very excited to have the opportunity to work on and help lead. It's a very important topic, obviously, to understand what we at Lux are going to be focusing on for much of the year to come, and what we think you all should be paying attention to in your planning and research and innovation efforts as well. So to start, I will talk a little bit about Foresight and our approach to selecting the top 12 emerging technologies that we identified. And then, as I mentioned, I'll bring in my colleagues to go over some of the highlights and dig into some case studies that from a few of the top technologies on the list. Then finally wrap up with a few thoughts about how you personally, for yourself and your team and your organization, can align to the best opportunities that these technologies present. So to think about foresight, it's a really important topic for us, obviously, at Lux. We spend a lot of our time looking forward to the future and thinking about, how's the future going to be different than the past, and what does that mean for the business and innovation opportunities? And I know it's really important for many of you in your jobs as well, even if it's not your job to do foresight per se. It's a really important input to your work as well. And really, one of the fundamental reasons for that is this FOMO, or fear of missing out, right? We look at the future and we think about that foresight because you don't want to be responsible for your company, your organization missing out on a big important new opportunity that maybe your competitors are taking advantage of, and you certainly don't want to be responsible for missing a big competitive threat that could be really disruptive to your business. But at the same time, foresight, it's about the future, and there's a lot of things that could possibly happen in the future. So it is a big challenge. Trying to dive in and think about foresight really can feel like starting to boil the ocean. So what we've tried to do in our foresight studies is to take a more systematic and more data-driven approach. So we've built tools that can help ingest and process thousands of different innovation data points and analyze those using tools like the Lux Tech Signal that provides this composite measure of innovation interest based on all these different inputs, and that can be a really strong leading indicator of commercialization trends and business opportunities. But the data alone isn't enough. We also really tried to combine that with the expertise of the analysts who are out there studying these markets and these business areas and seeing the paths that technology commercialization can take, and can bring in that perspective of what are the particular challenges or what are the particular needs that might help to affect the commercialization path of these technologies. And it's really by sort of synthesizing those two that we look out at the realm of the thousands of different technologies that Lux tracks and try to answer the question, which of these technologies are the ones that are going to have the greatest potential to transform the world, and that we should be focusing our efforts on studying and following over the course of the next year here. we've selected these technologies as the top 12 to be following for the year, and there's a lot more information and detail on each of them in that report and on our member site on our platform. We won't have the opportunity to really dig into all of these today. But certainly, if there's any questions that you have about the other technologies on the list, send those in to the Q&A, or reach out to us for a follow-up discussion here as well. And now, as I said, I wanted to pick out a few of the highlights from the list, and I'll bring in some of my colleagues to talk a little bit more about each of those. And what better place for us to start than with the top technology on the list, which this year was autonomous vehicles. You can see there's been an enormous uptick in innovation, interest, and activity, and certainly a lot of engagement around this and with our clients. And I'd like to bring in my colleague Chris Robinson to talk a little bit more about our work in autonomous vehicles and what we're seeing in this area. Chris, thanks for joining today. So autonomous vehicles landed at number 1 on the list, and I think that that probably wasn't a surprise to too many people. It is obviously a huge area of innovation interest and something we do talk a lot about. But I thought it'd be interesting to ask, what is it that you're seeing that's kind of unexpected, or that you feel like people are missing in this area of autonomous or self-driving cars?
Yeah, thanks, Mike. And there are a lot of possible answers to this question, right? I mean, commercialization timelines, the cost associated with it, or even just questions like what is the TRL for autonomous vehicles? But when I think about what's the most important thing is really thinking about ownership, and the fact that I don't think a lot of us are going to own autonomous vehicles because they're going to be expensive. It's not just about the sensors or the computers, which themselves add today tens of thousands of dollars to the cost of these vehicles. It's also thinking about the operational costs, keeping maps updated, the high cost of connectivity, because you're going to be moving a lot of data in and out of these vehicles, are going to mean your costs on an ongoing basis are going to be pretty high. And for personal car ownership, we use our cars maybe 5% of the time. So, part of what we think makes autonomous vehicles such a transformational and disruptive technology is really thinking about commercial applications. So, replacing car ownership with robo-taxis, or replacing, drivers in the logistics space with commercial vehicles used for logistics.
Yeah, I mean, that shift in model is sort of part of what makes this technology really attractive, right? Because it's just inherently, like you said, the regular cars would be sitting idle 95 or more percent of the time. It's sort of inherently a much more efficient use of resources if you move to that sort of model.
Exactly.
So sort of maybe just as a concluding thought here, what do you see as the kind of the next things, or the stuff that you'll be looking for the most over the course of the next year in autonomous vehicles?
Yeah, I think one is really the pace of the rollout. This is not a technology where we expect it to kind of be, oh, Waymo made this work in Phoenix, now they're going to deploy robo-taxis in every city around the US, around the world. Each city is going to have its own unique edge cases. You need to map these cities. You need to work with local regulators. And the feedback that we're getting from a lot of the autonomous vehicle companies that we speak with is that launching in a new city is in some way almost like launching a new product. So we do expect a fairly slow rollout of these solutions. But the other thing I'd keep in mind, kind of speaking directly toward clients, even if you're not in the automotive or mobility space, a lot of these companies that we speak with, there's an appetite for piloting and solving some real world use cases. So think about your own internal operations. If you're moving something from point A to point B, there's an opportunity to automate that, and it's worth thinking about that and maybe engaging with some of these startup companies or even larger companies like Waymo, and understanding, is this a process that we can automate in our own internal operations?
Great. All right. Thanks, Chris. And Chris will be back during the Q&A. So if you have any questions for him specifically, you can also keep typing those into that Q&A box. But let's move on and skip ourselves a little ways down the list now to talk about green hydrogen. This is a technology that's had a lot of innovation effort around it for a while. And green hydrogen means specifically hydrogen made from renewable electricity via water electrolysis here. So there's been a lot of innovation in that, a definite uptick over the last several years. But I'd like to bring in now Yuancheng Yu, who leads our energy research program, to talk a little bit about green hydrogen and why we see this as a really important opportunity. And I think that's probably the best place to start. Is right. You know, we've all heard a lot about hydrogen and been hearing about hydrogen in many cases for a long time. Why are we calling it out as a big opportunity right now?
Yeah, absolutely. I feel like 5 years ago, we asked the same question. 5 years before that, we asked the same question. But, you know, what's really changed this year is that now it's a country-led sort of initiative. Previously, a lot of the hydrogen work was driven by the private sector, specifically within automotive. But because of COVID, because of post-COVID recovery plans, and a sort of stronger emphasis on decarbonization, this time green hydrogen has been prioritized, and you're now seeing that top-down approach towards green hydrogen, which is really important. While it is a technology, ultimately it is an infrastructure play as well that's going to require billions, if not trillions of dollars eventually to truly scale up. And why we have it on sort of our top technologies to watch is not only because everyone in the energy sector is talking about it and it's really a big buzzword, but there's actually being money being put towards this. I think Germany is sort of the poster child of green hydrogen with their 9 billion euro national hydrogen strategy, not only looking at scaling up green hydrogen production, but also spending about 2 billion euros on global collaborations, which is going to be key. And they're not the only country. France, Portugal, I believe they have $7 billion euro plans, and other countries such as Canada, even Chile, as well as China are looking towards devoting part of their sort of post-COVID recovery and energy transition strategy towards green hydrogen.
Yeah, it is interesting you mentioned the post-COVID funding, that's actually been a significant driver for a lot of these hydrogen efforts, is the investments that companies or the countries are basically making in stimulus and directing a lot of that towards this technology area. So finally, maybe just a couple brief thoughts on, what do you see next in terms of industry adoption for green hydrogen, the highlights here to watch for the next year?
Yeah, as mentioned earlier, I think the really near-term low-hanging fruit will definitely be the chemical industry, petrochemical industry. They already consume most of the world's hydrogen today, and by opting to go for a green alternative, they're able to decarbonize their processes and also start sort of get the ball rolling on sort of a larger scale hydrogen economy rollout. However, in my opinion, that doesn't suffice or really support a true hydrogen economy. A true hydrogen economy is going to need industries that currently don't consume hydrogen to start consuming hydrogen. I think in the midterm, you're going to start seeing things around transportation. Just to be clear, Japan tried that about 10 years ago and failed miserably with fuel cell vehicles. However, I think they targeted the wrong application. The main focus was on light duty vehicles, and they did not foresee lithium ion batteries and electric vehicles taking off the way they did. But on the other hand, the real key areas are really going to be around heavy duty transport. So the harder to electrify, your Class 8 trucks, your long haul vehicles, your industrial commercial vehicles. From our analysis, we show that due to sort of range, due to time on the road, utilization, hydrogen is actually a better alternative than battery solutions. So we do believe that many of these companies or fleet operators will start to look towards hydrogen as a fuel source. Unfortunately, Nikola Motors probably set the industry back about 10 years with their debacle. However, there are several other developers who are truly making substantial improvements in this space, especially incumbent automakers like Daimler, who have now dedicated a fuel cell division just for their Class 8 trucks. So that's where we see that.
So thanks, here. We'll have a chance maybe to dive in a little bit more to some again during the Q&A. So any other questions you have for Yuancheng on hydrogen, type those in. But I did want to Thanks for and thanks here, and we'll bring everyone back for the Q&A here, but wanted to spend a little time on one more technology that is actually off the main list. One of the things that we did this year was to not just do our top 12 overall, but bring in our top 5 technologies for each of several key industries. And I thought it'd be interesting to also highlight one of the technologies that we, in this case, called out for the electronics and IT industry, which is digital biomarkers. And I'd like to ask Danny Bradnan, who leads our digital health research, to discuss this with us, because I think it is a really fascinating technology area. And Danny, to get us started, what are digital biomarkers?
That's a great question, Mike, and it's particularly interesting because it's a topic that's actually just started to get a name recently. It's only been about 2 years since there's been a journal of digital biomarkers available in the research realm. And the way that we're really looking at digital biomarkers is to consider them very similar to typical biomarkers. And if you're not familiar with the medical space, a biomarker is simply a piece of data. Usually it's something like a chemical piece of data or an image from a biopsy that allows a clinician to make a diagnostic decision, either to say that you have a disease or to help change the course of treatment. A digital biomarker is simply using a different kind of data. So digital biomarkers actually tend to focus on more environmental-based data, and their key defining features are that they are non-invasive. So you're not, drawing blood or spitting into tubes or having some kind of surgery done. You're getting something taken from sensors from wearables. And additionally, they're also continuously monitoring. So one of the real challenges of taking a biomarker from a single measurement like a biopsy is you don't often see changes over time, whereas continuous readings have this ability to detect, a decline in a condition or actually help direct a diagnosis itself. So really the digital element is this continuous non-invasive piece of the biomarker landscape.
Yeah, and also I think it's just interesting that it's data that's being collected anyway, right? Nobody has to go in and specifically, stick a needle in your arm or whatever, right? It's coming from the things that the microphones or sensors or pulse readings from the devices we kind of have around us all the time anyway, are being leveraged to identify these unique kind of biomarkers.
Absolutely. And that's, I think, the really great opportunity that we have, and that it's a super exciting opportunity for clients who are not in the traditional healthcare space, because there's a way to tap into a lot of the existing consumer IoT market. So things like smartwatches, smartphones, any kind of wearable you can think of, they're pulling off the shelf sensors and just having access to that data.
Yeah, and then I think the other interesting thing is that this, the opportunity here does go beyond the sort of hospital-based or medical sort of uses. So what is it that you're seeing in terms of, other opportunity in other industries where there's opportunities for these digital biomarkers?
So digital biomarkers are really, as I mentioned earlier, strongly leveraging these two paradigm shifts we're seeing in healthcare. Again, that earlier provision of care and the where care is actually being provided. And so there's this enormous opportunity for CPG companies that are, packaging things for food or, skincare or any of these peripheral wellness things that we often think of. They're able to leverage digital biomarkers to really tap into a demonstrable use of their product for consumers. So consumers can actually see actionable results from consuming a product, using a product, and they can do it in a way that is meaningful. One of the really key trends we're seeing in consumers is that they know healthcare is a big deal, but they're scared of that big, clinical regulatory element. And this kind of allows for a nice bridge that you can start to have clinical validation. You can start to see consumer buy-in for your product. And more importantly, you can start to, and this fits with a lot of the language we're hearing from a lot of our clients, aid customers in their consumer journey toward wellness.
Right. Yeah, and we can, I'm sure, have a chance to dig into some more of this a bit with Danny in the Q&A. But thanks, Danny. And just before we get to that, a few concluding thoughts. Do keep typing those questions into the Q&A box, and we'll take as many of those as we can. But a few thoughts just about how to really prioritize and align your own opportunities here, because we've said what the top technologies are overall. We've put in some of these industry specific assessments, and that's all important. But different companies in the same industry and different parts of the organization within the same company can have their own priorities. And I think it's also very valuable then to take that and to align these, which we've also done in the research here, is align these technologies to key mega trends. And you may have your own versions of these. We look at AI, data and analytics, climate and sustainability, workforce automation, demographic change, whether that's aging populations, urbanization, and so on, and globalization and inequality. But whether you use sort of our version of the list or whatever version, from your favorite consultant or that your company uses internally, you can take these top technologies and align them to these mega trends and use that as a further guide to think about, for my team, my organization, my business, we're really focused on, say, the climate and sustainability mega trends. So what are the technologies that are going to be the most prevalent and the most impactful for that? So finally, just by way of conclusion here, to sort of sum up, we believe very much, and as I think probably everyone on the line does, in the importance of foresight, but taking that disciplined and really data-driven approach is really a valuable way to effectively boil that ocean down to what are the real top emerging technology opportunities. And the industry view is very important, but also I do think that keeping an eye on these, those overall top trends and even the trends from other top technologies that are driving other industries is very important to be aware of as well. So don't just skip to your page, but look at some of what's affecting some of the other industries around you as well. And finally, we haven't really spoken, I haven't mentioned the pandemic yet. That's obviously going to have a big impact on the development and deployment over has had and will have an impact on deployment of many of these technology areas. But I do think that those mega trends remain consistent and are going to, in many cases have only been accelerated by the pandemic, and are going to be a big influence on future, continue to be a good guide to where future opportunities may lie. So as I said, we now have some time to take some questions. We've had a lot of those coming in, and I'll ask my colleagues Chris and Yuancheng and Danny to come back on here and let us know about some of their participate in that Q&A. I think what we're seeing is a few questions for Yuancheng around hydrogen. I think one of the biggest issues with green hydrogen, and this is what's I think has torpedoed it in the past, has been the issue of cost. So what do you see as the big things that are actually bringing down the cost of this technology today?
Yeah, so I think there's two factors. One is still just the capital cost of electrolyzers in general. There are still some incremental cost improvements the industry can make. Let's just be clear, electrolyzer technology is quite mature. It's been around for quite some time. The efficiency of electrolyzers haven't changed much in the last decade. But with all things that scale up in terms of manufacturing, there are some incremental cost benefits. I think that's the first one, but at the root of it's just the price of electricity, and ultimately the price of renewable electricity. Electricity is easily 60 to 80% of the total cost of green hydrogen production, and as we stand now, we're probably looking on average 4 cents a kilowatt hour, 4 cents euro kilowatt hour, and from our analysis, if we can get that down to about 2 cents euro per kilowatt hour. That really brings green hydrogen into the same price range as hydrogen from steam methane reforming. And that's really what's going to be the key driver. And this is why you see most projects for green hydrogen are in the Middle East, in Australia, in Northern Sea, where for renewable electricity is much cheaper. And that's where we believe are going to be hotspots for green hydrogen.
Yeah, great. Question for Danny on, someone wanted to hear the speaker's view about the agriculture industry's embrace of digital biomarker technology. So digital biomarkers for cows, for plants, for how do you see the opportunity there?
So I would like to preface this by saying that I mostly focus on human wellness. However, I am aware of a number of technologies, specifically with things like video monitoring and using computer vision for livestock, such that you can identify disease earlier. So in some cases, things like gait are heavily impacted by, and when I say gait, I mean the way animals move. Can be really impacted by disease, and so monitoring for changes in gait can really be a good early indicator of disease that allows you to catch it early and either treat the animal or sacrifice the animal for the betterment of the herd. So that's one particular opportunity. I've also come across a little bit about in plants, there's opportunity to use cameras to monitor for pathogen spread within particular plants. There are certain pathogens that are known for this. Weirdly, the turfgrass industry has been monitoring this for some time, taking images and analyzing them for pathogens, partially because there's a lot of money in turfgrass. And any early detection of disease means better play and thus better attendance by your club members. So again, while I'll say that, I mostly focus on people, there are plenty of opportunities in ag to really be looking at for leveraging these digital biomarkers.
Mm-hmm. Yeah, I think it is fascinating the way that can spread across some of these different industries. I was actually at an agricultural conference just a couple of weeks ago, and there was some really interesting discussion about it there as well. So I do think we'll see a lot more of that. So there's a bit of a general question about the list overall, if there is any big kind of themes or common trends in the technologies that appeared on the list this year. And I would say I think one of the most significant ones is, and not entirely new this year certainly, but really came home to me as we were looking at the list, is the impact and the way these technologies are going to enable and in many cases require new business models in order to commercialize or to sort of fully capitalize on these opportunities. So in my own work, I do spend a lot of time with our clients in the chemicals industry, and so something like materials informatics, which is number 10 on our list, right? That's an area where you can use machine learning to come up with new chemicals, molecules, or compositions, or new formulations and compositions. And so the way that can help to create more service-based business models, can help to facilitate essentially the automation and customization of formulations to different types of customers, really opens up some new types of business model opportunities in that industry. And I think, whether it's precision agriculture, which was also on the list, and shared mobility in the transportation space, there's a lot of these technologies that do require really, I think, as much focus on business model innovation to successfully commercialize as they do technology innovation to at least to really kind of manage that impact. So looking at some of the other questions coming in here for Chris, there's as I said, we didn't talk a lot about the impact of COVID, but I think one of the we have a whole other webinar on that, but one of the clearest trends that's been driven by that is a huge rise in e-commerce volume. So how do you see that overlapping with this, with the rise of autonomous vehicles?
Mm-hmm. Yeah, I mean, post-COVID, I think in general, before talking about e-commerce, we've seen an acceleration in interest. Of course, there were short-term disruptions. It's hard to design and test autonomous vehicles when you can't operate them and you can't be in the same room, of course. But really following some of the initial lockdowns, we're seeing accelerating interest. And in fact, just this week, over $800 million in funding has gone toward companies, building robotaxis, building autonomous vehicles for logistics. And I think the key reason there is there are clear problems that can be solved and money to be saved by adopting autonomy. And as I mentioned with the Walmart case, really we're looking at two specific use cases. One is moving loads between distribution centers, so more or less, looking at something like a fixed route. The second is more challenging, which is last mile delivery. And I say challenging because it's not as simple as just having an autonomous vehicle, drive to someone's house, apartment, et cetera. There are challenges like how do you hand off the parcel? Can you drop it on someone's doorstep? Well, not really if you're using an autonomous vehicle. So we've seen an investigation of can we put drones on top of an autonomous vehicle? Can we have different types of robotics, kind of get out of the vehicle and deliver that parcel? But suffice to say, COVID has been an accelerator for interest in autonomous vehicles.
I like the drones on top example. It's like I heard you like autonomous vehicles, so I put autonomous vehicles on your autonomous vehicles.
Yeah, and it's an idea that's really not as crazy as it might sound at first. I know we kind of had a chuckle, but the more we looked at it, it really did make a lot of sense.
Yeah. Well, that might also multiply the impact of this next question, which is about the legal aspects related to autonomous vehicles in the case of accidents.
Yeah, I guess in the case of accidents, there are kind of two different answers to this. When we talk about autonomous vehicles, today we've been talking about full autonomy, so your car is driving itself. But today there are a lot of systems available to consumers that do things like drive itself on the highway. The key distinction today with those type of systems is, and other types of level 2 autonomous systems is, even when you're using them, you are the driver. So it's a system kind of like cruise control where you're overseeing it. And this is also the case with Tesla's autopilot. So if you get in an accident with autopilot, you are at fault because it's not a system designed to drive the car itself, even though they might call something full self-driving, it's not.
Yeah, it's not.
In the future though, the driver is going to continue to be at fault for the accident. And in this case, if you're designing an L4 vehicle or an L5 vehicle, you're designing the driver. So you're going to be at fault.
Yeah. Right. I think we got time for one more question. It's also for Danny. What about the use of digital biomarkers for safety and security in the industry? Like making sure operators are not exposed to hazardous environments or they're fit enough to perform a specific operation.
Yeah, that's actually a really interesting question, and it's kind of an interesting use case blend that we're seeing in industry. So I guess to answer the first part of the question about not being exposed to hazardous environments, there's been a huge amount of interest in monitoring body temperature, not just for the immediate, oh Lord, COVID is happening and we need to be monitoring for body temperature because that's the best metric we have, but because heat stroke is a real risk in things like oil rigs, construction sites, and being able to monitor how an individual is dealing with that heat stress. Either they need more hydration or their heart rate variability has gone haywire. As a way to protect employees, that's a really important use case. Additionally, the movement-based biomarkers, so ensuring that this is a little bit of a, I would say, blend between edge case and whatnot, and between an actual digital biomarker and a functional employee management program. But being able to monitor that an individual's body positioning is correct, that your form is good when you're lifting, for example, is something that we're starting to see more and more in as a use case there. Of course, I have to bring up COVID. One of the biggest news around digital biomarkers has been this idea of being able to identify, and I'm going to be careful about how I say it because I know these companies are trying to avoid getting sued. They're very carefully saying things like being able to detect the likelihood that an individual is having an immune response as the result of a pathogen. They don't specifically say COVID at this time because it's really on the length of time we've had to collect data. We've had a very short period of time, but companies like Fitbit and Aura have launched these programs called Ready for Work that leverage digital biomarkers to identify when an employee is having an immune response that then alerts them to, hey, maybe you should work from home today, or you should, take a day off, which is something that we're starting to see a lot more funding in. The US Army just put a ton of funding into Fitbit's approach for COVID-19 detection, specifically for asymptomatic cases. And so there's a lot of activity in this particular space right now.
Great. All right. Well, thank you, Danny, and thank you, Chris and Yuan Sheng for joining us, and a really interesting, engaging discussion around these technologies. Thanks to all of you for joining the webinar today. Do feel free if you have questions for any of these fine folks or about any of the other technologies on the list to reach out and let us know. We will be sending out a link to the slides and recording shortly after this. And when you exit the webinar, you will also be directed to take a very short feedback survey. We'd really appreciate any input that you have there. So thanks again to everyone for joining us, and have a great rest of the day.